Astronomers know that planets around other stars beyond the solar system are common. But these planets are very hard to see and even harder to study. Fortunately, there is a clever trick that helps to separate the feeble glow of a planet from the dazzling glare of its parent star, exploiting the polarization of the light reflected from the planet. This method will allow future instruments on ESO's Very Large Telescope in Chile and the European Extremely Large Telescope to see otherwise invisible planets and even to search for signs of life beyond the solar system. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
In this episode of the ESOcast, we'll talk about a very special feature of light and how we can use it to detect planets around other stars. And we'll talk about a powerful new instrument that will exploit this feature, the Planet Finder Sphere, which will be installed at ESO's Very Large Telescope in early 2014.
Light is an electromagnetic wave. Usually, the plane containing a light wave can be in any direction, but sometimes one direction is more likely than others, and the light is said to be polarized. Several of ESO's telescopes can measure this polarization, offering exciting opportunities to find and study distant objects, including planets around their host stars. Take any star in the sky. Chances are that this star hosts several planets. One of these planets may even be similar to the Earth. But these planets are very hard to see in the glare from the bright star, as they are more than 1 billion times fainter.
Fortunately, we can use polarization to help us tease out the very weak light of the planet from the dazzling light of its parent star. So how does this work? Well, in many cases, the light we receive from the planet is actually reflected starlight that is scattered in the planet's atmosphere. Now, the scattering process produces polarized light, just like the light we receive from the blue sky here on Earth. Now, the point is that we can detect this polarization, that is, the preferential alignment of the light caused by the scattering in the planetary atmosphere, using state-of-the-art instrumentation on big telescopes.
Such an instrument, called Sphere, has been built and will be installed on ESO's Very Large Telescope in 2014. Sphere will take images of exoplanets. It will combine polarimetry with other methods to suppress the overwhelming light from a star and allow the very feeble light from any planets orbiting that star to be picked up and studied. The first requirement is to have a large telescope, such as the VLT, able in principle to take pictures that are sharp enough to allow us to spot any planets next to the star. But the Earth's atmosphere blurs the view, so we also need a clever optical system, adaptive optics, to take out this blurring effect as much as possible and bring most of the starlight together into one bright dot. The center of this bright dot is then blocked out by introducing a mask into the light beam to avoid swamping the fainter nearby objects. But even after all these tricks, a halo of starlight remains, much brighter than the planets that we are looking for. However, this halo is unpolarized, whereas the light from the planets is generally polarized. The new Sphere instrument we'll be able to pick out a planet's faint signal of polarized light from the unpolarized stellar halo. This trick, along with several others, will help Sphere to take images of Jupiter-like planets around other stars.
However, we don't just want to take pictures of the large exoplanets. We also want to get to the smaller, rocky planets close to their parent stars. But to do that, we need a much bigger telescope, one that collects much more light and provides even sharper images. The 39-meter European Extremely Large Telescope, or EELT. This giant telescope will be equipped with the next generation of exoplanet images.
They will use all the same techniques as Sphere, but take them to the next level. By using polarimetry as well as other methods, astronomers will be able to image rocky planets in the habitable zones around nearby stars. The polarized signal can also give astronomers vital clues on whether or not a planet has oceans and clouds of liquid water. And for larger Jupiter-like planets, it should be possible to study the light in enough detail that we will be able to actually see what the planet looks like. The ultimate goal is to one day spot the signatures of life on worlds beyond the solar system by finding evidence of oxygen or the typical green signature of vegetation.
Looking at exoplanets in polarized light may well turn out to be key in providing us with our very first signs of extraterrestrial life. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.